Hello everyone, so in this video series we are going to learn about integration by parts. So where do we start? We start with the product rule. Now why is that? Well, if you can remember, we started learning integration by substitution with recalling chain rule, because integration by substitution was the reverse chain rule, right? That is how we undo chain rule. Now integration by parts, is that how we undo product rule? So that's a question for future. But anyway, let's start with product rule. Now what is product rule? Where do we use product rule? Well, product rule, we use it in, of course, differentiation. And what product rule does is, let's say you have a function where f times g, it's a product of two functions, multiplication of two functions, f times g. Okay, that's the simplest case. Now you want to differentiate this product. What we do is we differentiate each function at a time. So the rule is that, okay, first differentiate f, that is f prime, keep g unchanged, do not touch g. Now keep f unchanged but differentiate g, then you get g prime. So let's do an example. Let's say you want to differentiate x times natural log x. Okay, so what you do is first you differentiate x, that is f, right? So derivative of x is 1. Now keep g unchanged, which is natural log x, plus now keep f unchanged, x. Now take the derivative of natural log x, which is 1 over x. Now let's simplify here. X cancel out, so 1 times natural log x is natural log x, plus here it's just 1, so this is the answer. Let's quickly do another example. Okay, so let's differentiate e to the x times, let's say, sine x. Now first differentiate e to the x, which is e to the x itself. Keep sine x unchanged. Now keep e to the x unchanged, okay, and differentiate sine, which is cosine x. So these are two examples of how to use product rule. Okay, just a quick review. Now let me write down the product rule again here. This is where we're trying to connect product rule with integration. But let's write it again. So you want to differentiate f times g, fx times gx. Okay, now let's keep some space here, because last time I tried to make this video, it looked bad without this space. So f prime times g plus, let's keep some space, fx times g prime x. So this is what I did here, is I rewrote the product rule again. Okay, alright, now what I'm going to do is I'm going to integrate both sides with respect to x. Okay, so let's integrate. Now on the right hand side, I can do the integration separately for these two terms because we have addition here. So okay, so I integrate all three terms. Alright, now let's focus on the left hand side. Now left hand side is very interesting. So let me show you something. Let's say we have a number triangle. It's a symbol, but it represents a number. Now let's say we multiply it by 2 and then divide by 2. What happens? Nothing, right? Nothing change. It's the triangle itself. 2 and 2 cancel out. Why is that? Multiplication and division, they are the opposite operations, right? So they undo each other. They cancel each other. Now differentiation and integration have the same idea, where differentiation and integration can cancel each other. Well, that's not the mathematically precise way to say it. We have fundamental theorem of calculus and definition of indefinite integral, but that's lots to take in. That's a lot of mathematical expressions, right? But simply we can say that integration is the undo button for differentiation, or differentiation is the undo button for integration, just like multiplication and division. So look at the left hand side. You want to differentiate f times g with respect to x, and then you integrate what you got. So really differentiation and integration cancel each other, right? And we get fx times gx, or by fundamental theorem of calculus, which we'll see in future. Alright, so nothing changed. We get fx times gx, just like the triangle here. But can we do that on the right hand side? Well, no, right? Because here it's a little bit complicated. Here you differentiate f, okay, with respect to x, but you integrate f prime times g. So that's a different scenario. So you can't do much there. You can't simplify it. Just write what you have, right? Okay. Now what I'm going to do is I'm gonna switch this term, take this term to the left hand side. So let's see what happens. Fx gx minus integral f prime x gx dx is equal to, okay, this term here. All right, now what I'm gonna do is I'm gonna change the left hand side and right hand side, swap both sides. So that means I'm gonna write this as the left hand side. Oops. So let's write it clear and big. So here we have fx g prime x dx is equal to, now this side becomes the right hand side, okay, minus f prime x gx dx. Okay, so what I wrote here, this we call the integration by parts formula. Okay, so this is the integration by parts formula. That's a lot to take in. Let's try to break it down. Now in this video I want you to see the big picture. Integration by parts is a big topic, okay, and you can mess it up easily. Okay, so here let's try to see the big picture. What is this means? What is the purpose of this integration by parts formula? Now let me take an example. Okay, don't take this too serious, just try to see what's going on. We want to integrate x times, let's say, cosine x. Now what integration by parts formula does is that, so what is given to you to integrate is x times cosine x. So this is equal to, we assume that this is equal to the left hand side of the integration by parts formula. That means x times cosine is not an integral that you can do right away. Okay, you can't use basic integration right away and solve it in one line. No, you can't do that. It's a complicated integral. Let's say it like that. So on the left hand side of the integration by parts formula, you have a complicated integral. Okay, now if you compare these two, let's say my f is x, right? I just go with the pattern. F is x, g prime x is cosine x, right? X is the first function written here, f is the first function written here, so I went with f to be x, g prime to be cosine x. But that doesn't work always, okay? So you have to choose f and g prime very smartly. Alright, you cannot rely with the pattern, but that we will learn in future. But don't focus on that for now. I just randomly choose my f and g prime. Okay, now what we want to do is, we know f, we know g prime. Let's try to fill up the terms here. So what else do we need here? Well, we need f prime, right? So what is f prime? Fx is x, f prime means derivative of x, which is 1. Now g prime is cosine x. Now you want g. What is g? G is, well, derivative of some kind of a function is cosine. So what is that function? Sine, right? Derivative of sine is cosine. Okay, so g is sine. Just I guessed it, or I mean I just used the simple idea, but I will show you the proper way to do it in next few videos. It's just we are focusing on the bigger picture here. Alright, so I know f, I know f prime, I know g prime, I know g. So I know everything that we have in this formula. So let's substitute everything into that right hand side. So first we have f times g. So what is f? X. What is g? Sine x. Minus f prime is 1. What is g? Sine x. 1 times sine x is sine x, right? Okay, so it's x times sine x minus, you just integrate sine x. Now what is the integral of sine x? Well, that we know, right? That is negative cosine. So negative, negative, positive here, cosine x. Alright, so I finished the problem. Now let's discuss. Let's discuss the bigger picture. Now see what really happened here. We started with a complicated integral. X times cosine x, too complicated to integrate. But by the end of the day, what is the function that we really integrate? We integrate sine, which was an easy integral to do, right? Now do you see the bigger picture in integration by parts? You have a complicated integral given to you. You identify f and g prime very smartly, so that by the end of the day, here, right here, you do a simple integral. You solve an solve a simple integral. Okay, so that's what you do. So you do a trade-off. I have a complicated integral, I will choose my selection smartly, so by the end of the day I will solve a simple integral. So we just use the integration by parts formula. Okay, so the bigger picture is, again I'm saying this: find f, decide f, decide g prime smartly. Okay, you cannot choose them randomly. Okay, we have to choose them smartly, which I will teach you later. After that, you decide what is f, what is g out of these two choices, and then fill out the right hand side of the formula. If you do it correctly, here you will integrate a super simple integral, and then you can find the answer for this complicated integral. So that's what happens on integration by parts. Okay, so in next video I will discuss more about integration by parts. I will discuss what are the common mistakes that you do, which is very important to learn. All right, okay, I'll see you there. Thank you very much for watching this video. Bye bye.